Good day and a warm welcome on behalf of NTI Audio. Today we are talking about a test setup, test procedure for headphones that have an active noise cancellation electronics included. My name is Markus Becker. I'm moderating this presentation and I'm assisted by Greg Schmiedle, our product manager. He is basically taking care of the incoming questions of you. To the left, you see the topics that we have prepared for today. We start with a brief overview on typical applications and benefits of ANC headphones. Then we will dig a little bit deeper into the technical realization of these items. And we will introduce you to the setup for device testing. Then we have a practical presentation prepared, which will be followed by a summary of the key aspects of this webinar and some additional hints. This webinar is a little bit shorter than usual, so I expect a duration of around 20 minutes. I guess you know, or maybe you already own a headphone with an ANC feature inside. It is quite common, quite popular, for instance, in passengers of airplanes who just want to have a quiet time during their flight. They want to avoid the annoying sound from the turbines from outside. So ambient noise cancellation is a big issue in both civil and military airplanes, aviation. Another application would be home theaters, where you want to optimize the sound quality. You want to avoid that external noise is disturbing your experience. Another pretty different application would be industrial environments. Here we're talking about hearing protection of the workers who are exposed to high sound levels, and ANC headphones can be a solution to this challenge. Another little bit more exotic application are sleep headphones. So if you want to just avoid that you will be waken up by your partner who is snoring, or maybe by another external sound source. There are actually specific headphones available on the market that provide this functionality, and they also typically include an ANC electronic. Another related application, even if you're not wearing a headphone in that moment, is the automotive market. Here the car manufacturers try to provide as smooth and as undisturbed environment in the cabin to you, with means that are based on the same technology as are used in ANC headphones. The benefits are quite obvious. Talking, for instance, about military pilots, they are exposed to lower fatigue. They can longer keep a higher concentration level in their action. We have an improved listening experience, a better audio quality, talking about home theaters, for instance, or of course, as stated before, you have a better sleep with the corresponding device. Let us take a look now on how an ANC phone is typically built up. So what is a fundamental part of every ANC phone is a microphone. Here we see the small blue dot that represents a microphone that is placed here at the outer shell of our headphone. Furthermore, we have a signal processor, which is represented by this green bar, just the electronics that keeps that signal processing electronic is shown here. And talking about the principle, we are basing it on destructive interference. Well, what does that mean? I'm going to explain that to you just in a second. Just one more hint. There are two different principles of realizing ANC headphones. One is called the so-called feed-forward ANC. Here the microphone, as shown in my sketch, is outside the ear cup. You're going to see the other alternative just in a minute. Well, now we have here the situation where there is a music signal coming through the wire. It is fed to my electronic. The electronic possibly amplifies it, replays it via the loudspeaker, and you can listen to the music. But now you have possibly a loud external noise, and this external noise is not perfectly shielded by your headphone, so you hear it in addition to the music. You want to have a clear music experience, but in addition, you have to listen to this environmental noise. So what the ANC headphone does is that it samples this incoming noise and it creates an inverse signal. So kind of a flipped signal. And if we sum up, if we add these two signals together, the result is that it doesn't disappear physically, it's still present, but here, for our hearing perception, it disappears because this violet arrow here represents the inverted signal. So the incoming signal from outside minus the inverted signal disappears, and you only hear the sound from the music player. This here is the second way of realizing an ANC headphone, that is the feedback ANC. Here we have the microphone inside the ear cup, actually in front of the internal loudspeaker. Now you can imagine the DSP knows the music signal it should replay. It also knows the actual signal at the output of the loudspeaker. And then it can calculate whether there is a difference, and it can take action to compensate for the difference. That is represented by this black arrow here with the blue rim. So that means that the DSP optimizes the signal in a way that only the music comes through. So in other words, any external noise which ends up here in front of my ear will be detected and eliminated. As well, for instance, and that is the advantage, the characteristic of my loudspeaker could also be compensated with this technology here. So summing it up, we have the advantage of the feed-forward ANC of being a very straightforward, rather simple to implement solution. And we have the more powerful feedback ANC, which, however, also requires more elaborate algorithms to become effective. Anyway, when we talk about testing, we need the same equipment, and that is here we need a binaural test fixture, typically with artificial ears. We need a calibrated external sound source. Calibrated means either you have a loudspeaker with a perfectly flat frequency response, or you have a loudspeaker with a very well-known frequency response that you can consider when you calculate the results of your measurement. Furthermore, we need an analyzer. The analyzer should be able to drive the loudspeaker, and also, of course, to analyze the signal from the test fixture. We have microphones here internally, and these microphone signals are fed back to the analyzer, which then calculates the measurement result. Of course, you need a device under test. Here in my sketch, this would be an in-ear earbud, could be also a headphone. And optionally, you may want to remote control your device under test to switch it on or switch it off, or to activate certain features. So here in my case, I'm using a mobile phone for that, a smartphone, which is connected to the device under test via Bluetooth. So here I can not only switch on and off certain features, I can also replay a test signal, which is important for specific applications. You're going to see that in a minute. The challenges are quite obvious. We need, of course, that the whole setup is established appropriately, that especially the acoustical coupling is working fine. We need an appropriate test procedure that covers all our demands. And finally, that will allow us to measure the headphone performance. That is our goal, to find out, for instance, what is the passive attenuation of our device under test. Every earbud, every headphone by itself, without being active, already has a certain attenuation. Then we want to determine the active attenuation of the headphone and the combined attenuation, passive plus active. In addition, we are typically interested in the frequency response of our earbud or headphone, and maybe there are even other parameters. I will come back to that at the end of my presentation. So right now, here I'm at the point where I'm going to show you in practice how this looks like. You see it's almost the same setup as shown schematically before. We have an analyzer, which is controlled by a PC via this FX control software. Then the FX100 is connected to the talkbox, which is my reference sound source. Flat frequency response. I have here the test jig with an artificial ear, and the internal microphones are directly connected to the inputs of the analyzer. In addition, I have a mobile phone that allows me to control the device under test that I'm going to put now in the artificial ear of my test jig. Okay, let me switch over to the software. You see it here. Now, the first thing I do is I try to determine the frequency response of my earbuds. And for that purpose, I have to replay a glide sweep test signal that comes from the mobile phone. I have already prepared that. I just have to start the test up here. Then the analyzer is armed. It waits for the incoming signal. And by pressing the button on my phone, the glide sweep is replayed. Okay, what we see here now are the two frequency responses of the earbuds in my test jig, the green one for the left channel, pink for the red one. So you see they are quite differing, and there is a pretty simple explanation for that. Apparently the left earbud is not correctly inserted into the test jig. So I'm going to redo that. I'm going to try again and restart the test. Now I have it. Now you can see the two curves are pretty close to each other. We have comparable wideband levels. So now we have a stable setup. Okay, let me flip over to the other project that I have prepared for you, and that will allow me to determine the attenuation of my earbuds. Just a very short first hint. Here we have the wiring of our setup. We have the two microphones that are in the test jig. This represents the talk box. I'm showing that because it's always very helpful when we work with FX Control, with FX100. This feature here, the hardware and wiring, because when you establish these connections correctly, you are always on the safe side that, for instance, the power supply for the microphones is adjusted correctly. Okay, what do we see here? On the left-hand side, we see the sound pressure level from the left earbud. We are only analyzing one earbud, the left one in this case. So here you will see the sound pressure level as you would hear it if the earbud would be in your ear. So that is a signal coming from the left microphone. And on the right-hand side, we see the attenuation. But let us start with the test. The system tells me to switch off the ANC, which I just did. Maybe you heard the pink noise in the background coming from the talkbox. So this curve now here, the blue one to the left-hand side, shows me the sound pressure at the microphone of the test jig behind the left earbud. And here on the right-hand side, you see the attenuation. So this is the calculated attenuation by comparing this reference curve. The black curve is the sound pressure without an earbud. That's my reference curve, and this is with an earbud, so the difference gives me the attenuation of the earbud. Now I switch on the ANC and start the second step. The red curve here now shows me the sound at the left ear if the ANC is active. And you see, especially here in the lower frequency range, we have a pretty high damping, or you can see it here, the attenuation is pretty high here. So the higher the attenuation, the better. And that is what you see. The pink curve to the right-hand side is the combination, blue plus red. So that is the combined attenuation, passive plus active. And I'm going to save this curve now, because I also want to show you another test that you can execute. Actually, it's a comparison, because this earbud that I'm using here has 2 stages of ANC, high and low. Now that was the high curve. And to make it better visible, I'm just I disable the 2 curves that I don't want to see. The green one is the kept curve, the combined kept curve. Now I redo the last measurement with the low ANC. And you see immediately the result. Pink is the new result. Pink would be ANC low. Green is ANC high. And here you see, especially again in the low frequency range, the ANC algorithm is pretty effective in the low frequency range. Now, as a last comparison, I want to show you another measurement, and that is by replacing my earbuds with a passive hearing protector. Again, I restart my measurement. And now you see the pink curve is the attenuation of the passive headset. The green curve is the combined attenuation of the earbud with active ANC. And you can see, especially here in the low frequency range, we are very efficient with our ANC, even much better than the passive headset. Only at the higher frequencies, the headset has a little bit a better attenuation. So this feature shows you, this graph shows you, you have a lot of possibilities to evaluate various settings, various situations, scenarios with active, passive earbuds, whatever, in order to optimize the performance or to verify it. Good. Back to my presentation. Summarizing the key aspects, you have seen 2 test signals. The pink noise you just heard for the 3rd octave spectrum analysis for the attenuation, or in the beginning, the glide sweep, which you unfortunately could not hear, but it was used to determine the frequency response of the earbud. Well, talking about the glide sweep, this is a very powerful analysis method, because you can even add more results to your measurement. So you can extend your analysis, you can measure the distortion, you can even measure rub and buzz, audible defects of the loudspeaker in your headphone, all in one single run, in one single test with this glide sweep signal. There would be a 3rd alternative available, the amplitude sweep. You could use that to determine the linearity of your earbud. So here we are slowly increasing the level of the pink noise signal, for instance, or another one, to determine how linear the earbud operates. Then talking about hardware, if you don't have a talk box available, you can use just a loudspeaker. In that case, we would recommend that you plug this SIP option into your FX100, because it provides a powerful amplifier that can drive the loudspeaker directly. You can even equalize it. So that is another alternative to the talk box that I showed you in my setup. If you want to even take a step further, if you want to determine the directionality, if you want to record a polar plot of your earbud, in other words, if you want to know whether the ANC works differently efficient depending on the direction from where the sound is coming. Then such a turntable might be a nice solution. It slowly rotates the device under test, for instance, during it is exposed to the test signal. And last but not least, if you want to automate your setup, then we would recommend such a Bluetooth box rather than using a mobile phone that you have to operate manually, because with the Bluetooth box, you can also automate the whole procedure, the communication to the device under test, switching it on and off, and so on and so forth. In any case, if you have such an application, if you need support, if you want to have the projects that I showed you, please let us know. We will be happy to supply that to you, to support you in every possible way to make your project successful. Well, that brings me to the end of my presentation. Me from my side, I want to thank you very much for your attendance. I hope I was able to provide some relevant information to you. And of course, I would be very happy to welcome you again at one of our future webinars. For the time being, have a good time, stay healthy. Thank you and bye-bye.